All right, ladies and gentlemen, today we're going to work on understanding like terms, and we've even got a helper, Little Miss Piper. Our objective is that we will develop academic vocabulary and accurately simplify algebraic expressions by combining like terms. This is a prerequisite for this 6th grade standard for algebra and functions number 2, which is to create equivalent linear expressions. So let's take a look. First, we're going to examine some academic vocabulary, combining like terms to simplify. Well, first, we need to know what like terms are. Like terms, by my definition, are two or more terms that contain the same variable factor. And that also means to the same power if there are exponents. So let's look at this example expression, 8x plus 1 plus 3 minus 4x. First of all, notice we have two values that do not have variables. Those are terms without a variable, and those are called constants. Oh, there's Little Miss Piper again, and she's got her glasses on this time. We've also got two variable terms in this expression, 8x and 4x. And a variable term is just any term that contains a variable, which is a letter used to represent an unknown number. In this case, we could also go a little bit more in depth to kind of explain what this value in front of the variable is called. This is called the coefficient. And again, this is the known factor in a variable term. Understanding the coefficient is very important because the coefficient is actually the value that you'll be combining when you combine like terms. Coefficient. All right, and I think I spelled this correctly, but coefficient, whoops, that's a T at the end. So 8 and 4 is the coefficient. Now we're going to do some practice determining which are like terms. So in this expression down here, which are like terms? All right. If you guess 3x squared and 6x squared are like terms, you are correct. Remember, they have the same variable factor, and if exponents are involved, they also have to have the same exponent. So 5x is not a like term to 3x squared and 6x squared because it doesn't have the exponent 2. Are there any others? You got it. 7 and 5, these are constants, and we've actually been combining terms like these since we were in kindergarten or 1st grade. You could add 7 plus 5 and get 12. When we look at the other terms left over here, 5x, again, we said, is not a like term because it doesn't have the power of 2, and there aren't any other terms containing the x variable. And 3y is the only term that has a y as the variable. In order to be like terms, they must contain the same variable factor, and if exponents are involved, they must have the same exponent as well. Moving on, now we're going to work on simplifying expressions by combining like terms. And once again, we got our little cheerleader here, Miss Piper. So go ahead and pause your screen, try to simplify this expression by combining like terms. Oh, by the way, combining like terms means that we are adding or subtracting, okay? Multiplication and division, they don't even have to be like terms in order to combine them. As a matter of fact, I could have a term like 2x, and if I'm multiplying by 3y to the 2nd power, I know these are not like terms, but in multiplication, I would multiply and get 2 times 3 is 6, and then I just bring down my variable x and my variable y to the 2nd power. So again, when we say combining like terms, we are specifically talking about adding and subtracting those terms. And again, you're just really adding and subtracting the coefficients. So here we go. Let's see how you did. 6x and 5x are like terms, so we can combine those. What we're going to do is actually just combine the coefficients. So we add 6 plus 5 to get 11, and the variable factor x stays the same, 11x. You may have also noticed that 3 minus 1 here, they're both constants, and we can simplify this. 3 minus 1 is 2. We've been combining constants ever since we were in kindergarten, probably. And our only term remaining is 4x to the second power. Notice that the exponent is a 2 on this x variable, and 11x does not have an exponent, so those are not like terms. That means that this whole answer is actually our simplified expression, 11x plus 2 plus 4x to the second power. And thanks to our commutative property of addition, you could actually put these terms in any order that you want, since they're all being added together. Next, we're going to look at this other example. Once again, go ahead and pause the screen, try to combine like terms, and then push play to see how you did. All right, let's check over it. I made this one just a little bit trickier to see how you would do. First, we should notice that 12x to the second power is a like term to 4x to the second power. That means that we can combine them. What we have to understand is that the commutative property of addition allows me to change the order of some of these terms, like this one, because it's plus 4x squared. And then I can combine my like terms. Whoops, I almost forgot my exponent. There we go. 12x squared minus p. And notice we can combine these like terms simply by adding the coefficients. So 4 plus 12 is 16. And again, it's x to the second power. Now I can bring all of this other information down. So I have minus p over here. And on this side, I have 12p. And I also have plus 5x. Plus 5x. And the plus sign comes down. Now I'm looking for any other like terms. Yeah, you may have noticed that we have 12p and we have minus p. Well, one thing I can do is I'm going to reorder these thanks to my commutative property. I'm going to bring this term over here and this term over here. The commutative property of addition says since we're adding all three of these terms, we can change the order without changing the value. Now you'll notice I've grouped up my like terms. Now, if you were thinking 12p minus p is equal to 12, that is incorrect because you'd be going from a variable term to a constant. When we combine these, we have to realize that a term without a coefficient actually has a coefficient of 1. So where we see minus p, this actually means minus 1p. And 12p minus 1p is equal to 11p. My other terms just come down, and believe it or not, I have my simplified version of this original expression is 16x to the second power plus 5x plus 11p. And again, that could be in any order that you want since we're adding all three of these terms. Our final problem here, let's see how you did. You should have combined 4y and 2y. Again, since we're adding these two terms, all we have to do is change the order, and when we combine them, we get 6y. Then we add in the other terms in this expression, plus 5x plus 3y to the second power minus 1. Notice we cannot combine any of the other terms because they don't have the same variable factor. to the same power. We have a y here and a y here, but this one has an exponent of 2. So my simplified answer for this original expression is 6y plus 5x plus 3y to the second power minus 1. All right, well, I hope that helped you out. And thanks to our little cheerleader, Piper, here, we'll see you guys later. See ya.